Assalamualaikum dear students. My name is ASIM'S, lecturer chemistry at Worcester College Vishal. Okay dear students, आज का जो हमारा लेक्चर है वो चैप्टर नंबर 7 से है जो कि है केमिकल इक्विलिब्रियम. ठीक है, चलिए डियर स्टूडेंट्स, सबसे पहले हम थोड़ा सा इसका इंट्रोडक्शन पिक करते हैं कि इक्विलिब्रियम क्या होता है. ठीक है, सो फर्स्ट ऑफ ऑल हम कुछ टर्म्स पिक करते हैं इस केमिकल इक्विलिब्रियम में. तो सबसे पहले जो है हम इक्विलिब्रियम स्टार्ट करते हैं. हम कहते हैं कि इक्विलिब्रियम बेसिकली क्या होता है. ठीक है, और फिर उसके थ्रू जो हम केमिकल इक्विलिब्रियम की तरफ मूव करेंगे. देखिए इक्विलिब्रियम क्या है. इक्विलिब्रियम बेसिकली हम उस स्टेट या पोजीशन को कहते हैं. ठीक है, दिस इज पोजीशन वेयर टू प्रोसेसेस, ठीक है, वेयर टू प्रोसेसेस or reactions becomes equal due to its rates. That is, becomes equal due to its rates. In that position of the two processes, जो physical processes हो या कोई chemical reaction में दो processes हो, like forward reaction हो, like reverse reaction हो, तो that state or that position is known as equilibrium. ठीक है, अगर लेट फॉर एग्जांपल हम इसको ऐसे भी पढ़ सकते हैं कि जो इक्विलिब्रियम है, हम इस इक्विलिब्रियम को दो तरह से पिक करते हैं. ठीक है, इक्विलिब्रियम को या तो ये इक्विलिब्रियम हम ये कह सकते हैं कि दिस इक्विलिब्रियम इज फिजिकल. जब फिजिकल स्टेट्स में, फिजिकल प्रोसेसेस में इक्विलिब्रियम एस्टेब्लिश हो जाता है, ठीक है, then that equilibrium is known as physical equilibrium. ठीक है, दूसरा हम इक्विलिब्रियम का टाइप पढ़ते हैं केमिकल इक्विलिब्रियम, जो कि केमिकल डायनामिक इक्विलिब्रियम कहलाता है. लाइक फॉर एग्जांपल, अगर हम फिजिकल इक्विलिब्रियम का एक जो है एक हेल्प लेते हैं, एग्जांपल लेते हैं इधर से, तो देखिए डियर स्टूडेंट्स, जब हम ये कहते हैं ना कि लेट फॉर एग्जांपल एक क्लोज कंटेनर हम लेते हैं. ठीक है, लेट फॉर एग्जांपल ये कंटेनर क्लोज है, इसमें हम यहाँ पे एक लिक्विड रखते हैं, लेट सपोज वाटर ही रखते हैं. ठीक है, लिक्विड इज वाटर. हम क्या करते हैं, हम इसको हीट करते हैं. ठीक है, इसको हीट देते हैं. यहाँ पे ये क्या बनाएगा, ये वेपर्स बनाएगा. ठीक है डियर स्टूडेंट्स, क्या बनाएगा, वेपर्स बनाएगा. यहाँ पे क्या करते हैं, हम इस कंटेनर को क्लोज रखते हैं. कंटेनर क्या होगा, क्लोज होगा. तो सबसे पहले जो प्रोसेस यहाँ पे हो रहा है ना, ठीक है, दैट प्रोसेस इज नोन एज वेपर फॉर्मेशन, इज नोन एज इवापोरेशन प्रोसेस. क्या कहते हैं, इवापोरेशन कहते हैं. ठीक है, इसके बाद कुछ टाइम बाद जो है कुछ वेपर्स कंडेंस होना शुरू हो जाएंगे इधर इस क्लोज कंटेनर में. सो दे बाउंस बैक. ठीक है, यही वेपर्स कंबाइन होकर दोबारा कंडेंस हो जाएंगे. तो हम यहाँ पे इसको इस प्रोसेस को कहते हैं. ठीक है, क्या कहते हैं इस प्रोसेस को, हम इसको कहते हैं कंडेंसेशन प्रोसेस. ठीक है, क्या कहते हैं, कंडेंसेशन प्रोसेस कहते हैं. So let dear students, so when the rate of evaporation becomes equal to the rate of condensation, तो हम इस स्टेट को कहते हैं कि जब इवापोरेशन का रेट कंडेंसेशन के रेट की इक्वल हो जाए, in that state that position for these two processes is known as equilibrium. क्योंकि ये एक फिजिकल प्रोसेस हो रहा है, इसमें कंपोजिशन में कोई चेंज नहीं आ रहा, that's why that's known as physical equilibrium. Okay, क्योंकि चैप्टर नंबर 7 is related to the chemical equilibria, chemical dynamic equilibria, तो हम इसको ऐसे पिक करते हैं कि let for example यहाँ पे एक रिएक्शन है where some reactants it converts to form products, और products जो है that bounce back to the reactant site. तो जब rate of forward reaction becomes equal to the rate of reverse or backward reaction. forward reaction क्या होता है, जिसमें reactants या reaction left side से right side पे चला जाए, that is forward reaction, जिसमें reactants products में convert हो जाते हैं. और रिवर्स रिएक्शन क्या होता है या बैकवर्ड रिएक्शन क्या होता है, जो प्रोसेस फ्रॉम राइट साइड टू मूव टू द लेफ्ट साइड, then that process is known as a rate for the reverse reaction and the process is reverse or backward reaction. तो इक्विलिब्रियम कब एग्जिस्ट होगा, ये तब एग्जिस्ट होगा when the rate of forward reaction becomes equal to the rate of reverse reaction. At that state, we know that this is a state of chemical equilibrium. क्या कहलाता है? केमिकल इक्विलिब्रियम कहलाता है. ठीक हो गया dear students? This is a general introduction related to equilibrium. Now we will move to some other terms in the chemical equilibria, chapter number 7. So the first topic is, let's dear student. So first topic is, that is topic number 7.1, and that is reversible reaction. Okay, reversible reactions and dynamic equilibrium. Okay, first of all, we have to learn about what is reversible reaction. What is a reversible reaction? So, dear students, we have to take a reversible reaction first. Reversible reaction. Okay, number first statement related to the reversible reaction. The reversible reaction is basically that one, a reaction which move in both direction. Like what? Like I can say that a reaction which move in the both direction, like that of forward and reverse process. Okay, dear students, and reverse. That is known as reversible reaction. Okay, the second statement for reversible reaction, you may define this one by this statement, or you can also define the reversible reaction by another statement. So what is the other statement? So we can write this one, a reaction which neither goes to completion. Rather, it moves in the direction of forward and reverse or backward. That is actually known as reversible reaction. So how we represent a reversible reaction? How we have to represent a reversible reaction? So we represent a reversible reaction by writing that reactants will move to the products and the product will bounce back to the reactant side. So you may also define the reversible reaction by this statement, and that is when the reactant move to the product by the process known as the forward reaction, that is forward, while when products bounce back to the reactant side, this process is known as backward process, or you can write for this one as reverse process or a backward direction process. You may write this one as well, that a forward process is that one where a reaction moves from left to the right side. And that is known as forward direction reaction. What is a backward or a reverse direction reaction, students? So that process where a reaction moves from right side towards the left side. And that is known as backward or reverse reaction. Okay, clear? Now let's take some examples. Some example of the reversible reactions. So now we have to take some examples. Like for example, I can write that nitrogen reacts with oxygen and it form nitric oxide, 2 moles of nitric oxide, which is the product. And when that product bounces back to the reactant side, and that reaction is known as a reversible reaction. and a reversible reaction is represented by this signs. It's a double head arrow, a half an arrow on one side and a half on another side. This is a representation of a reversible reaction. Okay, another example we have to take, like for example, hydrogen, it reacts with iodine and it forms a hydrogen iodide. 2 moles of hydrogen iodide. We have to take the balanced chemical equation. Or we can also write another example for this one, that nitrogen, it reacts with hydrogen, 3 moles of hydrogen to form 2 moles of ammonia. This is also a reversible reaction. You may also write another reaction for that, another example of reversible reaction. That calcium carbonate solid decomposed to form calcium oxide solid and carbon dioxide gas. This is also a reversible reaction. So okay students, now we have to pick in that reversible reaction that what is the forward and what is the backward reaction or reverse reaction. So if we have to pick this difference of the forward reaction, that what is forward direction reaction, and we have to compare it with the reverse or backward reaction. We have to pick some point in it, in the reverse reaction. Okay, so what is forward reaction? The first point is that reaction is forward. Okay, reaction direction which move from left to right, side, and that is known as forward direction reaction. Now if we differentiate between the two, then which one will be reverse? So reverse direction, that direction reaction which move from right to left side, and that is known as reverse reaction or reverse direction in the case of reversible reactions. Okay, next point is the forward reaction or forward direction reaction is that one where reactants converts into products. It is reactants converts to products. That direction of a reaction is known as forward direction reaction. Okay, then what is reverse direction reaction? And we can write, so when products converts back into reactant, site, and that is known as the reverse or backward direction reaction. Okay, in the case of forward reaction, concentration of reactants decreases in this direction. It decreases, and products concentration will be increased, and products concentration increases. In the case of forward direction reaction. Okay, then what is reverse reaction? In reverse reaction, concentration of products decreases. Look now, why the concentration of products decreases? So in this reaction, the products is basically bounce back to the reactant side. That process is a backward or reverse reaction. So concentration of products, that is converts into reactant side, into the reactants. That product is known as the that process where the product concentration converts into the reactant side, that is known as reverse reaction. And here we have to pick another point, and concentration of products in this process decreases and reactants increases, because there is conversion occur of the concentration of product into reactants, where the concentration of product gradually decreases. Okay, Okay, now let's speak that what is a dynamic equilibrium. We have to take note that what is a dynamic equilibrium. So let's speak a dynamic equilibrium. Okay, dear students, so let's speak dynamic equilibrium. So dynamic equilibrium. That what is a dynamic equilibrium? Second term in the topic 1.7. Dynamic equilibrium or equilibrium, point number first, we have to learn this point first, that this is occurs in the closed container. Occurs in closed container. The container must be closed in the closed vessel. Okay, the second point is that this is occur in the closed container, and the second one that is occurs in a reversible reactions. In a reversible reactions. Dynamic equilibrium basically that is achievable in the closed vessel in the closed container. And the second one that occurs in the reversible reactions only. So we have to take now the definition of the dynamic chemical equilibrium. That what is dynamic chemical equilibrium? So look, the stage or the position, this is the position in a reversible reaction, where rate of forward and reverse reaction becomes equal. That becomes equal. Is that position is called dynamic equilibrium position. This is dynamic chemical equilibrium. Why we use the term dynamic? So basically the process is going to happen. The forward direction also occur, the reverse directions also occur at the state of the equilibrium. That's why that's known as dynamic equilibrium. Okay, the second statement we have to take for dynamic equilibrium, the second definition. And that is the point is that the position in a reversible reaction, where no change in concentration of products and reactants occur. In reactants occurs with time. So F with the time, there is no change in the concentration of products and reactants occur with the time. In their position or their state in a reversible reaction is known as the dynamic equilibrium position, or their state is basically known as dynamic equilibrium. Okay, dear students, so we note the point that dynamic equilibrium is that position when the rate of forward and reverse reaction becomes equal to one another, or this is the position in the reversible reaction when there is no change in the concentration of reactants and products. In that position is also known as dynamic chemical equilibrium. So let's represent it by a reaction. So let, for example, I will take a general one, that there is a reaction where reactants converts to products and the products bounce back to the reactant side. So the process where reactants converts into product is known as forward direction reaction, and when the product bounces back to reactant side, that's known as reverse direction reaction. So when the rate of forward reactions becomes equal to the rate of reverse reaction, then that state is known as dynamic equilibrium state. I repeat, this is dynamic chemical equilibrium. Okay students, how we represent a chemical dynamic equilibrium by graph? How graphical representation of a dynamic equilibrium to occur? So let's take another one, graphical representation. Graphical representation. You may focus on this one. You have to keenly observe this graphical representation. Okay, so let's look here. Let, for example, the first representation for this start of the general reaction. Let, for example, if I state that with time I want to check the reaction and how much reactants converge into product and how much product bends both check to the reactant side. Look, initially reactants with a high concentration, and initially at the start of the reaction the products are found to be zero concentration, because initially there is no product, there are no products present in a chemical reaction. So with time there is change in the concentration of reactants occur, and with the time the concentration of reactant becomes constant after some time. And also the concentration of product increases, and with some time the concentration of product also becomes equal to constant. Then that state in the reversible reaction is known as equilibrium position. So that, for example, look, from this graph how we will pick some ideas. So look, some basic ideas you must pick from this graph. The idea number first. If I say that at equilibrium, what is the concentration of reactant and product in this graph? So you will clearly write this one, that the concentration of reactants is equal to that of concentration of product. That is according to this graph. Or you can also write that, dear students, another idea. At equilibrium, when concentration of reactants and products equal, you may write at the Kc, equilibrium constant, that is equal to 1. And there is another idea, dear students. Another idea is that the completion of reaction, you may write that this is equal to 50%. Now these three ideas are very important for this graph. 1. At equilibrium, concentration of reactant and product are equal. The second one, Kc is equal to 1. What is Kc? Kc is actually a constant of equilibrium in terms of concentration. We will pick that in the second lecture. And the next one, the completion of reaction is 50%. Okay, look, the second graph. We have to pick the second graph to represent a chemical equilibrium. The second graph is that, look, if I again state that, if I plot the concentration, what's this time for the reversible reaction, reactants more and products are zero at the initial state. So with the time there is a decrease in the concentration of reactant occur, and eventually it becomes constant, while the concentration of products with the time increases, and after some time it becomes equal to constant, but with no change with time. If you look to this statement, no change with time. So look, if I state that this is the concentration of the reaction with time, and this is the concentration of product with time. So look here, now the three ideas from this graph I can pick that at equilibrium. Okay, number first, at equilibrium, what is the idea? So number first, at equilibrium, concentration of reactant is more from that of concentration of product. You will clearly observe this one represent the concentration of reactant at equilibrium, while this one represent the concentration of product at equilibrium, which is less from the reactant. Second idea, the Kc, now in that case, will be less than 1. Then what will be the completion of reaction? Then completion of reaction is less than 50%. Because at equilibrium, more reactant and less products present. So reactants are not more to be converted into the product according to this graph representation. And there is a third and the final graph for the dynamic equilibrium, chemical equilibrium, and that is locked to the third one, that if I plot the time versus concentration of reactant product graph, reactant initially more, products are less. So with time, there is decrease in the concentration of reactant occur and eventually it becomes constant. And with time, there is increase in the concentration of product occur and eventually it becomes constant. So remember that the concentration of product at equilibrium is more from that of concentration of reactants. So what idea I have to pick from this graph? So the ideas are at equilibrium, I can pick that products concentration is more from the reactant. So products are more from reactants. So when the products more from the reactant, and in that case Kc will be greater than 1. When Kc is greater than 1, dear students, then completion of a reaction should be more than 50%. Okay, so that's all about the chemical dynamic equilibrium. Look, I will summarize it. A dynamic equilibrium is that one which must be occur in the closed vessel in the closed container, that must be occur in the reversible reaction. This is not for irreversible reaction. We define this dynamic equilibrium by two statements. Other usage that reversible reaction when rate of forward and reverse reaction becomes equal like this one, which I represent here from a reaction. And the second statement is that position in the reversible reaction when there is no change in the concentration of reactants and products, which I represent here by graph. By graph number 1, by graph number 2, and by graph number 3. Hope so you all understand the introduction of chapter number 7, which is reversible reaction and dynamic equilibrium. Okay, Allah Hafiz.